All right, so when we talk about momentum, what do we mean by momentum? Momentum is the product of mass into velocity. So, momentum is written by symbol P, and it is mass into velocity, where mass is in kilograms, velocity is in meters per second, and momentum is in kilogram meters per second. So momentum is the product of mass and velocity. Now, when we talk about our momentum, so momentum is basically related to the concept of inertia, right? What is inertia? Inertia is the ability of a mass to resist its change in motion. Okay. So if you have got two cars or two vehicles that are moving towards you, okay, one vehicle is much smaller in size, and the other one is a huge truck. So if I asked you that, Hajra, which one would be harder to stop, you would say to me, Miss, obviously the big truck will be much harder for us to stop. So that is because the bigger truck has greater inertia. It has greater ability to resist its change in motion. So that when I try to change the motion, when I try to stop it, it will not stop. So that is inertia, and that is related to the concept of momentum, right? That truck is going to be harder for me to stop. Why is it going to be harder for me to stop? Because the truck will have greater momentum. It has greater mass, hence it has greater momentum. Now, when we are going to go ahead and we're going to talk about it, so for momentum, there's a simple concept related to momentum. What is that concept that is related to momentum? That concept is basically that momentum is always conserved, right? And we call it the law of conservation of momentum. So the law of conservation of momentum basically states that momentum before a collision is equals to momentum after a collision in an isolated system. To understand what this law means, let's take a look at a few example questions. Okay, so let's say that we have a question in front of us that says that we have Mhm. We have a trolley that has a mass of 4 kg and initial velocity of 5 meters per second. It collides with a stationary trolley that has a mass of let's say 2 kg and its initial velocity is 0. How will you know, Hajar, that it's 0? Oftentimes examiners will use the term stationary. Okay, so they will say it was a stationary trolley. So that's how you know that the trolley is not moving and the initial velocity is 0. So oftentimes they will not tell you that the velocity is 0. They will simply write down stationary or at rest. So it will be your job to figure out that, all right, if it's stationary, if it's at rest, it means that the initial velocity is 0 and you take that into account. Then the trolley number 1 is moving towards the stationary trolley. The two trolleys collide with each other and then they move into opposite directions, let's say. Trolley number 1 moves off with a speed of 2 meters per second. So the examiners are saying to you, please find out what will be the speed of trolley number 2. So we are going to use a certain formula. What formula are we going to use? We're going to use a formula that M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Basically, Hajar, the formula is initial momentum is equals to final momentum. So U is the initial velocity and V is the final velocity. Okay, so all you have to do is put the values in the formula and get your answer. So your M1 is 4 kg, U1 is 5 plus M2 is 2 kgs, U2 is 0. M1 again trolley 1, the mass is 4 kg, the velocity. Now what will you write down as the velocity? 2? No. You'll write down minus 2. Why minus 2? Because now the direction of the trolley has changed. First it was traveling to the right, now it's traveling to the left. So velocity is a vector quantity, just like that momentum is a vector quantity. So we are always going to do what? Always going to remember to add the signs to our velocity. This is a very important part of the chapter. This is a mistake that students make a lot. Like they won't put the negative sign when there is a change in direction. And as a result, they get incorrect answers. So the change in sign, this is what you have to be really careful about in this chapter, is that when you see the change in direction, include that in your formula. Include a negative or a positive sign with the velocity as needed. Plus M2 is 2 and V2, we don't know what the value of V is. That's what we have to calculate. So 4 5s are 20 plus 2 zeros are 0. So plus 0 is equals to 4 minus 2 will give you minus 8 plus 2v. So 20 plus 8 will give you 2v, and 28 is equals to 2v. So v is equals to 28 upon 2. So v is equals to 7 meters per second. Right? This is how you can go around and do your calculations. This is the formula that you can simply go ahead and use. Okay. So this is the formula you can go ahead and use. Now, let's take a look at another. This is a sort of a split, one type of question that you will see in momentum. You'll encounter different types of questions. Let me share another type of question with you. Let's say, again, I'm taking 2 trolleys. The velocity is 2 meters per second, and the mass is 1 kg. It's moving to the right. Let's me do it this way. Then I have another trolley that is velocity is 3 meters per second. That's moving this way. And the mass is 4 kg. Okay. Now, what happens that when the two trolleys meet up, they stick together with each other. This is also a scenario. That's why I'm now doing another possible scenario that you can get in the exam questions. After the trolleys collide, they stick together with each other and they move off towards the right, and we have to find the velocity. So again, what are we going to do? We're going to use the formula. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. M1 is 1, U1 is 2, plus M2 is 4, V2 is, U2 is 3, is equals to M1. Again, we need the mass of trolley 1, so that is 1. What is the velocity of trolley 1? We don't know, so we write down V. Okay, plus M2 is 4. And what is the velocity of trolley 2? That is also V. That's the main thing you have to realize in this question, that both trolley 1 and trolley 2 will have the exact same velocity because they're moving together. If they're moving together, then they'll have the same velocity. There's no other option. There's no middle choice. There's no middle option, right? If both of them are moving together, that means that they both will have the same velocity. This is the trick to these kind of questions. So both of them have velocity v, same velocity. So now you solve. 2 plus 12 is equals to 1v plus 4v. So you will get 5v. So okay, now Hajra, 1 second. Sorry, I have made a mistake in my calculations. Can you spot what mistake I've made in my calculations? You can take your time, look at the calculations I've done. I have made a mistake in my calculations. Can you figure out what mistake I've made?
I'm not really sure what the mistake is.
Okay. The mistake is this, that do you see that trolley number two is traveling towards the left hand side while trolley number
Yeah.
one is traveling towards the right hand side? So for trolley number two, I should have taken the velocity as negative. That's my mistake. Okay. That's what I said. Always pay attention to what the direction of the movement. They're traveling in opposite direction. So one of them has to be positive and one of them has to be negative. So you can make trolley number two positive, but then make trolley number one negative. One of them
So
has to be negative. Yeah,
why would you take it as negative? Because isn't don't you take
opposite
negative
direction.
when the
Because
oh,
it is in opposite direction. That's why. Okay.
okay.
So the negative sign does not actually show that the value is decreasing. The negative sign shows that it is simply in the opposite directions because velocity is a vector quantity. This is true with all vector quantities, Haja. If you have force, then if the force is in opposite direction, how will you show the examiners that the force is in opposite direction? You add a negative sign. Or if you talk about any vector quantity, right? For example, even current. So if the current is traveling in opposite direction, we would take it as negative. Remember, alternating current goes positive, negative, positive, negative. So in physics, a negative sign doesn't always mean that the value is like less. It simply means that if it's a vector quantity, then it simply means that there is a change in direction. So that's why it is very important that you take the negative into account. Because if I don't take the negative into account, I will do 12 plus 2. But now I will do 12 minus 2. Okay. So and I will end up with a different answer. Now, over here, it is completely up to you, Hajra. You can take whoever you want positive and whoever you want like negative. If you want to take trolley number one negative, you can do that as well. But just make sure one is negative. Like if they're two trolleys and they're both in the opposite direction, so one of them has to be negative. So generally, though, it's easy if you just make it a rule that I will take right positive and left negative. So that just makes it easy. But speaking from a physics perspective, it doesn't matter. As long as they're in opposite direction, just show one, whichever one you like, as negative. But if you just make it a rule for yourself, just for yourself, that right is positive and left is negative, that just makes it easy. So now my values will be completely different, right? Now I'm going to get 2 minus 12 will give me minus 10. And minus 10 divided by 5 will give me my velocity as minus 2. So now you can see, Ajra, that it will actually not travel towards the right hand side. It will travel towards the left hand side because the value is coming negative. Negative doesn't mean that it is value is less. It simply means that the trolley will go in opposite direction. So if right is positive and left is negative, so the trolley is going to go to at the speed of 2 meters per second, but it won't go to the right, it will go to the left. Okay. So this is why the direction is so important. If you don't include the correct direction, your entire value can come out incorrect, like mine was.
So whenever the um
Yeah.
for example we have the trolley where you say if the whenever it goes to the left
Take it
direction,
as
is it
negative.
always going to be negative?
Uh, okay. It's not necessary to always make the left negative. You can also make the right negative. Just Hajra, one of them has to be negative. Either
Okay.
make the right negative or the left negative. But general, my advice to you is just choose one and stick with it. Okay. Like
Yeah.
for you, make it a rule for yourself. It's not a physics rule, but you can make it a rule for yourself that for myself, I will make right positive and left negative. So that makes it easier to solve question. But speaking from a purely like theory perspective, you can make any positive, any negative, doesn't matter, as long as you make one of them positive and one of them negative. You can even change for different questions. It won't change your answer. But my advice is make one rule and just stick with it for yourself. It will make it easy for you. So this is basically what how your momentum questions are solved. Now, when you're looking at your topic of momentum, so another thing that you have to remember is that I told you that momentum before the collision is the same as momentum after the collision, right? And I gave you this equation. I told you momentum before is equals to momentum after. m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Another way of writing the same thing is that change in momentum for trolley A. I'm saying trolley A, it can be a ball A, whatever object is given to you in your question. Change in momentum of A is equals to change in momentum of B. This is the same concept, Hajra. I'm just rewriting it in a different way. So, for example, I'm going to write down 1, 2. Sorry, let's just do 1, 2 because we've been talking about trolley 1 and trolley 2. Let's stick to what we've already done. So, if I want to find the change in momentum, to find the change in momentum, Hajra, we use this formula. So let's say our final momentum, let's talk about trolley 1. So final momentum of trolley 1 is m1 v1, right? Velocity, we will take as the final velocity, minus the initial momentum. Initial momentum is m1 u1. This is equals to, now do the same thing for trolley 2. The final of trolley 2 is m2 v2. And the final of trolley 2, initial of trolley 2 is m2 u2. This is the same formula as above, but I've rearranged it. I have moved all the trolley number 1 to one side, okay? And I have moved the trolley number 2 to the other side, okay? That's all I have done. This is the same formula that is rearranged. So remember this, that if the examiners have already made you calculate the change in momentum of trolley 1, so the change in momentum of trolley 2 will also be the same and you can directly get the answer, okay? So this is the same concept. I've just written it down as two different ways. So you can either say total momentum before. So this is the total momentum before. Momentum of trolley 1 and momentum of trolley 2 that I've added up. Okay. And then the momentum of trolley 1 and momentum of trolley 2 afterwards that I've added up. You can either write it down like this or you can think of it as trolley 1 altogether and trolley 2 altogether. Okay. The answer will come out the same way either way. Now, when we talk about the change in momentum, this brings us to the concept of force. Force is equals to rate of change of momentum. And this is one of the definitions that is given of force. So force is equals to change in momentum divided by per unit time. So force is equals to m1 v1 minus m2 m1 u1 divided by 10. Okay, so you find the change in momentum, you divide it by time, and you'll get force. Change in momentum, by the way, is also known as impulse. There's another term for change in momentum. Another term for change in momentum is impulse. So if the examiners say find the impulse, you know what they're talking about. They're talking about the possible change in momentum. So this is what we are actually going to see. Okay. Now, the thing is that, let me tell you something interesting. Do you know how Newton's second law, right? Newton's second law, often students think that it is F is equals to ma. It's not. Newton's second law is actually force is equals to rate of change of momentum. This is Newton's second law. Students think it is F is equals to ma. It is not. It is this. Force is equals to rate of change of momentum. Now, the thing is that if you take this equation, Hajra, and you solve it further. So let's say that I take the mass as common. What do I get? V1 minus U1 divided by time. Now, initial final velocity minus my initial velocity divided by time. Isn't this a very familiar formula? This is the formula for acceleration. Acceleration is equals to V minus U upon T. So F is equals to ma. This is how you get the formula F is equals to ma. Okay, so F is equals to ma is just a derivation or a further solving of the concept that forces change in momentum divided by time. Making sense, Ajra? Any part that's not clear or confusion regarding anything?
No.
Perfect. So that is all there is in your topic of momentum. So we are going to go ahead and now take a look at some questions on our topic. Give me a minute. Let me share the questions with you. All right, the question says a ball of mass m falls vertically and hits a hard surface. Its speed on hitting the surface is v1. It rebounds vertically upwards with the speed v2. What is the change in momentum of the ball? My advice to you, Hajra, is to draw a diagram of what is happening here to help you get the correct answer.
Would it be the last option?
No, that's why I said draw a diagram. It will really help you out. Look, I'll guide you. So what is happening, Hajra, that we have this ball, okay? The ball is moving downwards. Then the ball hits the floor. After it hits the floor, it moves upwards. There is a change in direction. That's why I said draw a diagram. The ball is hitting the ground, it's moving downwards. When it rebounds, it moves upwards. So if this velocity is v1, then this is minus. Okay? Okay. So now you're going to do that mass into change in velocity, right? That was what the formula I taught you. So mass into change in velocity. That's how you figure out the change in momentum. So how do you find the change in velocity? You subtract v1 minus v2. But now over here, Hajra, you will realize that v2 has a negative sign. So v1 minus v2. So m multiplied by v1 plus v2, because minus minus will become plus. So correct answer will come out as option C. Okay, that's why I said the direction is really, really, really important. Okay, because if you don't take the direction into account, you can get an incorrect answer. Making sense how we're solving it about and how we're getting the option C?
Yeah.
All right, I want to share another question with you. 1 second, please. For a lot of your momentum questions, my advice to you is for paper two, right? Draw a diagram. I promise you it will help. It will actually really help you out.
Okay.
That's the scenario. A small ball of mass 0.1 kilograms travels horizontally at a speed of 600 meters per second. It strikes a stationary wooden block of mass 1.9 kg resting on a frictionless horizontal surface. The ball stays in the block. So the ball hits the block and then it stays there. What is the speed of the ball and the block immediately after the impact? So this is similar to the second type of question I taught you where objects stick together and then they move together. So the ball and block are sticking together and they're moving together. So you need to figure out the final velocity. Hajra, do you need any help with the question?
No, I'm just about to put it in the
Okay, okay,
calculator.
it's okay. No worries, no worries.
I got my answer as 30. So the first one.
Yes, you are right. The answer is going to be 30. Correct. Good job. All right. Okay, Hajra, we'll go ahead and stop it over here for today, and we will continue in the next class.